So I will write the algorithm for binary search. The syntax may be more like C++ syntax, but I am writing pseudocode. Algorithm binary search. So what are the parameters it needs? It needs three parameters: low, this one, and high, and key value that we are searching. So which key we are searching? So this is key. So these were the parameters. Then what we were doing every time? We were finding out mid. Mid is low plus high divided by 2, and we have to take the floor value. Then we were checking whether the key is present at A of mid. If a key is equals to A of mid. If you remember, we were getting the middle element, this one. So we were checking whether this is the key element that we are searching for. If so, suppose we are searching for 27, then it is found. It is found. So return the index mid. That is, this is the index, it is found. So return it. No, if the key element is smaller, then check on the left hand side. So else if key is less than A of mid. So if it is on left hand side, we were modifying high to mid minus 1. So high should be changed to mid minus 1. If it is not equal, if it is not less, then it must be definitely greater. So we have to check on that side and modify low to mid plus 1. So modify low to mid plus 1. So else we will modify low to mid plus 1. This is what we were doing. So we have to go on doing this until the element is found. Or if the element is not there, we should stop when low becomes greater than high. So this means we have to do it repeatedly. How long we should do this? While low is less than or equal to high. We should continue this. So we should stop when low becomes greater than high. If low became greater than high, then we stop, means the element is not found. So we can return -1, saying that the key element is not found. So this is a iterative procedure that is using loop for binary search. I have just shown the algorithm or pseudocode, though it is more like C++ code, but the perfect executable code I will write down when I show you the program. This binary search algorithm is written using loop here, that is iterative version. We can also write a recursive version. So let us write a recursive version for performing binary search. Algorithm R binary search. What are the parameters it needs? Same parameters, low, high and key. So low, high and key. These are the three parameters. Now as it is recursive, so it will be calling itself. So what is the first thing we should check? Whether there are some elements or not. So we should check that low should be less than or equal to high. If low is greater than high, we cannot perform anything. So we will check first thing, that is if low is less than or equal to high, then only we will consider. So if low is less than or equal to high, at least there is one element. If low is greater than high, means there are 0 elements. So first condition we check. Then after that we will find out mid, and mid is low plus high divided by 2, and that is floor value. And we check if key is equals to A of mid. If so, then the element is found, so return mid. So it is similar. Almost it is similar. Else, if the element is on the left hand side, check if key is less than A of mid. If key is less than A of mid, then we have to search on the left hand side. So this procedure can call itself recursively for searching on the left hand side. So say return R binary search, R bin search. So this is recursive call. So what it has to pass? Low as it is, but in place of high it should be mid minus 1, and key as it is. So this is a recursive call with modified list or reduced list. So it is just passing left hand side list. So if mid is here, from low to mid minus 1 it will be passing. So if the key is less, it is on the left hand side. Otherwise key is greater and it is on the right hand side. So else return R bin search mid plus 1 and high as it is and the key also. That's all. If low is less than equal to high, do all these things. If low is not less than equal to high, then return minus 1. Means key is not found. So this is a recursive procedure for performing binary search upon an array, and assume that array is global. So I am not taking any parameters here. Otherwise array should also be taken as parameter. If it is not there, means we should assume that it is global in algorithms. So these are the iterative procedure as well as recursive procedure. Now if you observe that recursive algorithm, it is tail recursion. See, at returning time there is nothing. Either it performs this recursive call or this recursive call, and after the recursive call, so there is nothing it has to perform. So it has to check for the element that it is checking beforehand only. So in this portion it is checking for the elements, right? It is checking for the elements. Then after that it is calling itself. So at returning time it's not doing anything. It's not doing anything. So instead of writing a tail recursion, you can also write a loop iterative version. So already we have discussed that tail recursion and loops are similar. So if you have to write tail recursion, better go for loop. So this procedure is better because this uses a stack. Internally it uses a stack. Now next we will do the analysis of binary search.